All right, we may move on just because there is a fair bit more to go through, and this challenge is semi-infuriating if you can't solve it. And I want to get onto more interesting things than cryptography. No offense, Leo, who may be online. So just a couple of things on this challenge, right? You inspect element and you're a hacker, right? Not really, but if you live in Missouri, then you probably get sued for it. If you've heard about this news story, a reporter that found teacher information in the source code was getting sued for hacking, and they've since dropped the charges because that's on them, not the reporter that just so happened to find all the social security numbers on a web page by mistake. Cool, so let's move on to something a bit more technical, which is going to be SQL injection. Now, if you've ever done SQL injection or you've never heard of what SQL injection is, then I have a demo that's probably going to be better at explaining it than I am. But basically, firstly, show of hands, who here has no idea what SQL is? Anybody here actually programmed in it before? Couple of hands. All right, cool. We assume that sort of be the case. For the purposes of today, you don't need to know a lot, and I'll explain everything that you do need to know. So effectively, SQL is a database, or rather, sorry, it's a language for interacting with databases, and it's done by using these things called queries. Now, here we have a random bank website, and also a log that will show us what happens. And if we try and log in using a valid set of credentials, which it gives me here as user@email.com and password, very secure. If we log in, oh, I forgot how this thing works. It's trying to explain us how that works. But basically, I sort of forgot what this is trying to do. There we go. Okay, here we go. So if we have a look, and hopefully everybody can see, there is this statement here that says, select star from users where email equals something and password equals something, right? Now, in a normal SQL query, we can basically say that we want to select, the star means everything, so select all the data from users, which is just a table, where the email is any email and the password is the password that is provided, right? And now if we entered a valid username and a valid email, and we actually had that in the database, it would return all that data. In SQL injection, we're basically taking advantage of that fact that the code will just execute what it's given and the database will just return what it's told to return in order to break it or get information out that we're not supposed to. So what this example was, it was telling us to put password and then an apostrophe. Now, if you have a look over here, you can see that we now have a double apostrophe. Now, when the SQL query tries to execute that, it sees that there is an open string and nothing following it. And it's like, okay, well, I don't know what this is. And it throws an error. Throwing an error means that when you put something in and it throws an error, that means that it might be vulnerable to SQL injection. So as you can see, it says the application crashed with an unexpected error. What could that mean? And that means the character that we inserted messes it up in a certain way. The reason that this works, and we're not going to go into like preventing SQL injection attacks, but basically whenever you're dealing with user inputs, you always need to be doing this thing called sanitizing, which is basically in one way or another telling the code, this input that I'm giving you is user input. It should be a string. It is not relevant to the query except for the thing you're searching for. If you don't do that, you're vulnerable to SQL injection. So here's what the code looks like behind the scenes. We can see that over here, I don't know why I went over here when it's also there, but anyway, we've got password and then limit 1. So limit 1 is a statement in SQL which basically says return only one result. But you can see that it's actually purple and it thinks that it's a string because we've inserted an extra apostrophe, and so it's being treated as a string. SQL's like, nope, can't understand what this is, throws an error. We can now take advantage of it. So if we put password in again, we can see that without the apostrophe, limit 1 is valid SQL. An extra apostrophe, it turns into a string. Same thing if I did a, in this case, no, it wants it to be a single apostrophe. Get this out of the way. So because we're not sanitizing it and we're just saying, all right, the user inputted this, let's put it straight into our query, we can now exploit it. And this is what's causing the syntax error, as it says. Cool. So how do we take advantage of this? I mean, it's sort of up there, but let's kind of hide this. Any ideas? Yep, exactly. So the way that it works, or the way that a normal SQL query works, is it says select, in this case, everything from users where the email is equal to the certain email and the password is equal to the certain password. But what if we just said that the email is equal to whatever, in this case, user@email.com, and the password is password or true? Now it's just going to say, well, let's find anything from our user table where the email is that specified email and true, right? Which just means it's going to find anything with that specified email. So how do we do that? We can basically, you can't just say or true, but what we can effectively do is we can say the password as being an apostrophe to close the string that it's looking for, or 1 equals 1. And I will get to those dashes in a second. But if we try and put in a apostrophe and then or 1 equals 1, we can see that it's actually interpreting that or 1 equals 1 as SQL. It's no longer part of the string because we closed it initially with the first apostrophe. The last thing you'll notice is that while we still have that trailing apostrophe from earlier, what do we do to get rid of that? The answer is we just comment out the rest of the query. Now, this is when you'll need to start doing a bit of trial and error, hint, hint, wink, wink for the first challenge. But different languages have different comment syntax. In this case, it is dash dash. In other languages, it may be a hashtag. But as you can see, when we put in a dash dash, the rest of the statement gets commented out. And so the final thing that we have is select all the information from users where the email is equal to user@email.com and the password is just true, effectively. And when we try and do that, we'll see that if this thing gets out of the way, we get in, right? This is a very basic SQL injection. It gets a whole bunch more complex from there, but for today, that's pretty much all you'll need to know. We'll start building it on in the future, but from now, that's pretty much it, right? So this is basically how we do SQL injection. We take advantage of the fact that there are unsanitized inputs, and we use it to put in our own SQL query, and then we go from there. I'm pretty sure that's it. Yeah, and as it says, the dash dash comments out the rest of the query, because if we didn't do that, it would still have that trailing apostrophe and it wouldn't work. Cool. So in order to actually test it, we have our own banking website, which if this lets me get out, that would be great. So if you go to bank.monsec.io, you'll come up to this fun page. And if I go back to the notes, there are 4 things on this web page that you will need to do. The first one is bypass the login screen using SQL injection. There's 2 things that are in green. Those are ones where there are no flags. You just need to be able to show that you did it. Once you have done it, like just raise your hand and I'll come and give you the points manually. And then there is a 4th hidden thing somewhere on the page or somewhere on the website that you need to find. Once you find it, like you'll be fully aware of the fact that you found it. But yeah, for now, go to bank.monsec.io. We'll continue working on that for a bit, and then we'll move on to cross-site scripting. If you do finish all the MonBank stuff and you finish the other 2 challenges from before, then I'll let you start the cross-site scripting stuff in advance. But yeah, last thing is please do not brute force the architecture. You do not need to. So please don't start brute forcing usernames and passwords. It is SQL injection only, right? You're not going to be able to guess the username and password. So please don't. Cool. But I'll make it so that you can actually see the challenges now as well. I think that's readable. As a bit of a hint, this is effectively what the SQL query is on the back end, right? Where there are spaces, that is where you can input your own text, and it's not sanitized in any way. The challenge isn't getting past the sanitization. It is just simply getting past this query. Now you can do this in multiple ways. Because you don't know what the username is, you may want to try and get past that to begin with. Okay, I think in the interest of time, I may just give people the initial solution, and then so we can continue from there.
I'll just jump in quickly. There's still a little bit more pizza. If anyone's still hungry, come and grab some more pizza.
Cool. So for the couple of people who have managed to get it, which is great. For everybody else, I apologize for clearly explaining it in a very terrible way. But basically what we're going to do is, and I'm going to try and bring it up on a thing where it doesn't immediately give you the answer. Cool. That's not an actual email and database. That's mine, so please don't try it. All right. So basically, if we have a look at that query, and hopefully everybody can sort of remember it, it is on the board, but I doubt any of you can see it. We basically have select all from users where user equals whatever we input and password equals whatever we input. Now, there's two ways about going this. If you happen to know a valid email, you can put it in. Now, you all don't. So we need to actually be able to get past the fact that we don't even know what the email is. The easiest way to do that is to basically SQL inject and say that we don't actually care about, like we don't have a email. So we're going to select every email and then go from there. So the first thing that we need to do is, and I will zoom in a bit so everyone can hopefully see, we need to close off the initial string. If you remember, the way that it works was it said and like where users equals and then open quotation marks. So we're going to first close off the quotation marks. We're now able to insert our own SQL query, and we're going to say where close quotation marks or 1 equals 1. So that's the very first step, and hopefully most people got there, which is good. And this is basically saying we're going to select everything, right? We're effectively getting rid of the actual like thing checking for the users. And if we try and do that, we'll see that it flashes an error, right? So we know that we're doing something, but we're also getting an error at the same time. Remember that there was another step that you needed to do, which was you needed to comment everything else out. And the reason why I said we're using MySQL specifically is because in MySQL, the 2 dashes only works at the end of a query, but a hashtag works at at any point. So if we put this in and we fill in password, well, now we don't get anything. So we're sort of closer-ish maybe. But the last thing we need to think about is what this statement is actually doing. And what we can basically see is that we're selecting everything from users and then true, right? So we're selecting everything from users. The problem is when we're doing this normally, we're only expecting to see one user, right? The page doesn't know how to load it when we have like 3, 4, 5, 1,000 people that we are trying to load the data from. And so the final thing that you needed to add before the hashtag was limit 1, which is basically saying only get the first result. So if you do that, and you just put in whatever for the password, it doesn't matter because it's all getting commented out, it doesn't work. Because I didn't put the number 1. Let's try again. Limit 1, and now we're in, right? So it's a whole bunch of different things, and if you haven't done it before, I'm pretty sure I didn't get it the first time either, so don't stress. But now from here, you're able to get into the page, right? Now you can do the rest of the challenges. I'm going to move on to the last thing for this workshop, which is cross-site scripting. It's not on this page. So if you do want to have a crack at it, either don't listen to me, which I wouldn't prefer, or do it afterwards, which I would prefer. But basically, if I go back to the slides, and all this stuff is achievable, like you can go to bank.monsec.io whenever you want, it will remain up. If you don't get a chance to complete the challenges now, just send me or Marcus a message on Discord, and we'll give you the flag to submit. But yes, let's go on to the final thing for this week, which is probably not necessarily the easiest, but maybe the most feasible to grasp out of SQL injection and cross-site scripting. We're basically, let's say that we have a bit of JavaScript code, and I'm sorry if you don't know JavaScript, everything in web is JavaScript, so it's kind of hard to get past it. But let's say that we have some sort of hypothetical code that displays a name based on a user inputted value for name. And you can sort of ignore line 2 if you've never done JavaScript or HTML before. And it says let message equals hello in bold, then the value of name, and then closing a bold tag. And then it basically just displays it, right? This is hypothetical code. It won't work, but it's just to demonstrate what's going on. So normally, let's say that you put in a input as, Ari as a valid name, or at least I hope my name's valid. When we put that in, our message becomes hello and then in bold, Ari. So that works, assuming that we have the right input. Now, let's assume again that the input isn't being sanitized. So whatever we put in is what is being displayed straight away by the page. What happens if we instead put something else, like our own JavaScript code? Let's say instead that we put script alert1 and /script. If you don't know what this does, search it up because you'll need it. But now what happens is our message becomes in bold and then script alert1. And when we run this on an actual page where cross-site scripting is possible, the web page doesn't actually know that what we've inputted isn't valid HTML, or it's HTML that it shouldn't run. And so it does display it, and you get cross-site scripting, or in this case, what's called reflected cross-site scripting. There's 2 different types. We're not going to go into it in a heap of detail because it's not really relevant for this. And also, I didn't manage to get cross-site scripting on Google. I'm not that good of a hacker, and if I did, they'd probably sue me. So that's, for reference, not actual cross-site scripting. That's just in the console. So where is this useful, right? It's sort of not, it's not really helpful if I just like throw different concepts at you and you're like, okay, great, that's it. This is a thing that exists. But this is actually on Twitter, as you can probably tell. And if you haven't seen this code before, this is cross-site scripting in a program called TweetDeck, which is something that basically allows you to tweet it's an extended functionality of Twitter. And somebody actually found cross-site scripting that they could store on Twitter, and then what it does, it self-retweets. This person got 62,000 retweets in a very, very short period of time, because as soon as anybody loaded that message, it retweeted itself automatically. And then everybody else saw that, it retweeted itself automatically. So cross-site scripting does exist in a lot of websites, or it certainly did. It's hopefully a bit less prevalent now. But this is one type of real life example of where this type of exploit was used. Now, there's a whole bunch of YouTube videos explaining how this works. I certainly do not have the expertise to explain it, but what we are going to do is get you guys to do a couple of basic cross-site scripting challenges to sort of build yourself up. So on top of all the other challenges that we've kind of pushed through, there are 6 levels on this website called xssgame.appspot.com. It sort of ramps up in difficulty. The flag, I will point out, for each challenge is part of the description of the next challenge, because it's not our own website, because these types of challenges are really hard to set up. Because it's not our own website, there are certain words that are being used as part of the flag. The instructions are in the challenge, which I will make available in half a second. But that's pretty much it. That's it for this workshop. We haven't done a lot of content in terms of explaining it, because I'd much rather you guys just try and figure it out yourselves. And then we help you as it is, rather than me just lecturing for 2 hours, which would be probably quite boring. So if you have any questions, obviously feel free to ask. If you need to go, by all means. And yeah, if you have any questions afterwards, or you solve any of the challenges that don't have a flag, please message me or Marcus on Discord. Join the Discord already if you haven't. Thank you, everybody. And next week, you will require Kali. So we will send out instructions on how to install it, because next week we are planning on going through basics of Kali Analytics and also a couple of tools that will help you to automate effectively the things that we do yesterday and today. Last week and today. And as I said earlier, start forming your own teams for the beginner CTF. It's heaps of fun. So yeah, thanks everybody, and let me know if you've got any questions.